There are two formulas that we're going to use for finding the area of non-right triangles, and it's just going to depend on what information you're given for which formula you're going to use. So the first formula says that you have area is equal to 1/2 AB sine C. The way you're going to use this is if you know two sides. So if I look at the very first problem, I know two sides and I know the angle between them. It's called the included angle. So that's when you're going to use this formula. So area is equal to 1/2. A and B don't matter as far as which one's which. It's just the two sides of the triangle. And then of course I'm about to write cosine, but it's the sine of the included angle. So sine of 50. This gets directly put into a calculator. Do not, pass to go. Do not collect $200. Throw it right in a calculator. Make sure it is in degree mode because our angle is in degrees. So the area of this triangle, we don't know its units, so let's just go ahead and say it's 91.93 units squared. I'm going to use the U term for units. Area is always something squared. And we've found the area of that triangle. It can be that straightforward. So the next problem, again, we know two sides and we are given the included angle. So set up the equation here for area. Area equals 1/2 one of your sides times the other side times the sine of the included angle. So whip that directly into a calculator. Let's see what we got here. Times 8 times 5 times the sine of 112. And the area of this triangle is 18.54. Again, we'll call it units squared. Unless the directions say otherwise, continue to round to two decimal places. So that's if you know two sides in the included angle. The other formula is something called Heron's formula, or you might actually look it up and see what's called Heron's formula. So basically, we've got a two-part formula. What you're going to do first is you are going to find the S value. The S value is called the semi-perimeter, okay? And basically, semi-perimeter, basically you're going to find the perimeter and chop it in half. And then once you know the semi-perimeter value, you're going to use that S value with your A, B, and C, which are the sides of the triangle, in this formula, okay? So if we know all three sides of the triangle, we can apply Heron's or Hero's formula. So the first thing in the first problem, we're going to find the semi-perimeter, which means we're going to do half of the sum of the sides. So half of the perimeter, semi-perimeter. So let's see, 6 plus 8 plus 10, chop that directly in half. We get a semi-perimeter of 12. And then we're going to use this S value in the area formula. So area is equal to the semi-perimeter times the semi-perimeter minus one of the sides, semi-perimeter times minus one of the other sides, semi-perimeter minus the third side. So all of the S values are all the same number of 12, and then we just subtract one side, and one side, and to fill in the rest of the problem. So square root of 12 times 12 minus 6 times 12 minus 8 times 12 minus 10. Into the calculator it goes, and we get an area here of exactly 24. Again, we don't know our units, so we'll call it U squared. And there's your answer. All right, sometimes it's really straightforward like that. Let's take a look at problem number 2 here, see if it does the same thing. So first things first, semi-perimeter. We're going to find half the perimeter. So you find the perimeter by adding up the sides. Semi-perimeter is going to equal, I believe, 9. I want to double check that. I did it in my head. But just to make sure, yep, it is 9. So then we're going to find the area by using that semi-perimeter and subtracting all of the sides from the semi-perimeter. So into the calculator it goes. And just to make sure that you don't, you subtract the right sides, meaning the correct values. So I've accidentally done this before where I forget and duplicate. So in this case, I've got 3, I've got 7, I've got 8, and I'm subtracting them out from the semi-perimeter. So area in this case is 10.39. We'll call it units squared. And that is how we're going to use the two different formulas to find the area of non-right triangles. Please let me know if you have any questions or concerns